Today we're going to walk through just Dockerizing a Python app. It's going to be some basics, and then we'll go up to kind of some mid-level stuff while we do this. Yeah, so this app, it's kind of I've been involved in the Python developer group for a long time, one of the longer standing admins. And so we have our own bot, obviously, like a lot of groups on Discord and Slack and everything. And I keep playing with the idea of using new Python features to build a new version of it. So this bot is very much in the infancy, but what it does is, sorry, let me make sure it's actually added to the team. The whole point is I want it to be composable for other people to be able to use it, either in their app directly or to, and it's going to pop up the wrong Slack, either in their app directly or just add plugins if they want. So that's what we're going to be demoing. So it just does a simple like quota stock kind of thing for now, and that's based on plugins.
Cool.
And so we're going to start through, let's see, I'll publish all this obviously afterwards. But one big thing with demos, I always I get lost sometimes in the commands people run, so I made a makefile, which is just something simple. So afterwards we can reflect back and see, oh, this is how we ran different things. But we'll not focus on that in a moment. So getting started, this bot requires Redis to be up, and you can, so this gets broken. And so to do that, you can either run Redis on your host or run it in something else, like online or in a container. So for fun, we can run Redis just locally here, and we're gonna be able to, let's see, we can test this port. Oh, sorry about that. That's the wrong one. So right now I can't access this. This is running in Docker, but right now the way the networking is set up, they isolate it from my host system. So we're gonna kind of gloss over this a little bit right now, but this network is separated from my host by default. But since Docker has its own networking layer, you can actually connect to it in the container here. So I'm pointing with my fingers instead of my mouse. Used to do these in person sometimes. So yeah, so you can actually link these containers to access Redis or Postgres or RabbitMQ, whatever kind of stuff you're running your app with. So in this case, I'm actually gonna restart this one with the port allowed. So we could Redis CLI from my host, which I don't actually think I have installed. Oh, I do. So now we can actually see that, and the bot can connect to it. So that's running again. So this, now that we've exposed the network, we can see it from our host. But we kind of run into an issue with pretty much any programming language you're going to work with a runtime, where it's hard to share this stuff, especially when you talk about like Python. And I don't know how many of the folks here are Python people or 100% Python or just partially, but dependency management Python has long been kind of a pain point for us. We have like pipenv, poetry, obviously just raw pip, which is what I tend to use. And so if I want to share this app or develop it with my coworkers or the open source community on our Slack group, it's hard. It's really hard. So you have to set up a virtual environment. You have to know which requirements to install. You have to know all this stuff just to contribute. And if you're like coming in, popping in, want to help out on a project, that's a lot of overhead just to write a line of code and contribute it on GitHub or wherever you might be. So one nice thing here, and what Docker really enables us to do, is we can make a shareable image that people can use to build and run their apps. Sorry, grab a little Coke here. So what we're going to do, let's walk through just setting this up. This is all stuff you'd probably do on your desktop or laptop normally. But we can automate all the steps for somebody else instead of like giving them a makefile like I have here. So we're going to do kind of just the quick and dirty Docker file, and we'll walk through each instruction just to get it going. So you always have a from, and then you just give it a base image. And I always like the Alpine images because they're tiny, which is awesome for download speed, deployment speed, all that. There's some nuances and the differences, but we can talk about that later if we have time, and if not, something to follow up and research. So in doing this, we need to, this is optional, but you can set like where you want to work in the container. So all steps going forward are in this context of work of /app. And then you have to add your dependencies, obviously. And this is where you can see it really is nice to start trying to remember all these for this app, because sometimes I forget. It's hard off the top of the head, but I have some notes, obviously. But yeah, so you can see, let's suppose I send this to somebody. I'm running on Windows right now, trying out WSL to see if the Linux kernel here can support my daily needs. But I'm on Windows, and then I can send it to somebody with Mac with this, and if they need to install GCC and G++ and Make and whatever else our app might need, you run into some kind of crazy headaches, I think, because it's like, oh, depending on how their system's set up, it's different, and it's not reusable, it's not shareable. We can copy in our application, then we can run again. So run commands run in the context of the build. So this is when we do Docker build, not when the container is actually running. Let's see, requirements. We'll do production right away. You don't have to specify this exposed, but I have a friend who told me, I thought this was really smart. You can use it for documentation. Like if your app is always going to be running, hopefully on a port, if it's a web app, exposed is just a nice way to document it. And it helps with certain things like traffic, which we'll talk about in a little bit. And let's see, so I'm struggling to type at the moment. Wow.
It's the hardest part of demos is typing in front of people.
Yeah. All right, let's see. All right, so like I said, everything runs in the context of the build until you hit this one, and this is just what the command is going to be in your app, in your container when it starts. And hopefully this doesn't take super long to build. Just as one side note, if you're following along or just getting started with Docker, the output may look a little different than this. This is a new feature called build kit. I don't know a ton about it yet, other than I set the variable, so it looks, I like the formatting a little better. But Peter, you probably tell me why it's better.
Yeah, I'll talk a little while it's running there. Yeah, so it's the latest and greatest build engine, and it's composable. You can run it in different places. It has better caching. It also does you can do parallel builds, so it looks at your Docker file and says, oh, I can run these steps in parallel with these steps, and then at the end it can bring them back together. It also does like dependency checking. So if you have multi-stage builds and you trigger a stage that you want to build, it then knows what that build is dependent on, and it'll only build those dependencies and won't build everything that's in your Docker file.
Oh, that's cool.
Yeah, and then the caching is really great feature, so it speeds everything up. You can preload caches and stuff like that.
Oh, that's very cool.
Yeah.
Yeah, so I should have popped out the C dependency of this one, because this one takes a few extra seconds.
Yeah, no worries.
But I think one thing I'll gloss over here a little bit is, so right now this basic file that we're running is it's building a container that we can ship off to, like, I don't know, Amazon or whatever, or Swarm or whatever we want to deploy with. And what it does right now is anytime I change anything, this whole build process, so this couple minutes we're waiting, will run every time if anything changes in these what are called layers. I think they get a little more advanced. We'll fix this Docker file in a minute to talk about those specifically, but I guess just take me on my word that if every time we rebuild this right now, it's gonna, or every time we try to run this, if we change any code, it's gonna rebuild everything.
Yeah.
I think last time I clocked this was 140 seconds, I think, but we'll see.
Here we go.
It's gonna make me wrong. It always does. Of course.
You got the added little talking to me on GoToWebinar with taking up a little bandwidth probably or something. That's my limited knowledge of networking.
Yeah, I actually pruned some of the system images just so we could show exactly what people see, because another thing is sometimes I get confused with when I watch others. It looks a little different. Here we go. 166, 172. All right, so not bad. And since we did not, oops, sorry. Let's see, I didn't tag this, which is whatever. Running it's harder. All right, so you're gonna try to run. It's in a boot loop because right now environment variables aren't there, which is something I overlooked while prepping that part. Let's see. I put them in secret, so we're gonna probably have to step past that one. Actually, yeah. All right, so this, like I said, it runs and right now it's boot looping. But right now we want to be able to access it. Let's just do a simple one to kind of show what I wanted to show here. And this is the same port issue. What this container was, or I guess the bind issue, is in the Docker file. One thing I did, and this is kind of a funkiness, not a funkiness, it's just how networking works. I set this bind address to localhost. Running in dev, that's usually what you'd probably do. Obviously, if you're like at a coffee shop during the normal world, you're not going to want this exposed to the whole world. It's just working on your laptop. But in Docker, that'll actually be isolated to this networking stack. So similar to Redis when we first started, that would be visible on my host, so I can't, hit that locally. So from there, I think normally we'd have to link this to the network, similar to that Redis CLI again. I got the wrong folder. So again, we have to link these containers. So when you're talking about like a single application, it's kind of something simple where you have like this, you have Redis and your Python app. It's pretty easy to spin these up manually side by side. Like this one I spun up and then we ran this. We ran this where we can just run these locally. It's not a huge burden to run these side by side. When you start thinking about larger applications, stuff we work on at work, stuff we work on like in our free time, that's a bigger project, or things you want to deploy, where you start thinking bigger, where you have background workers, like in the Python world, since our apps are generally, people call them slower, you have background workers for mailers and background jobs, all that kind of stuff. It starts to become a huge burden to share that with people. And so in doing that, to make that simpler, we have a tool that we can leverage called Docker Compose. And what this does is very aptly named, you can compose a bunch of different pieces together. So in our case, for this specific application, it's the application itself, and then it's the dependencies, so Redis. And so, like I said, spinning it up is kind of a pain. So we can actually make it even easier by building a Docker Compose file to compose these two things together and really just define what our application needs at any given point. And my favorite part is if you version this in Git, which I think you should, with your application, you can actually, at any point in time, you can go back 6 months ago and run the app then without much headache. And in Python too, a big issue that we've talked about a little bit with dependency management is there's an old adage of like, friends don't let friends use system Python. And what that means is you don't install pip packages or Python packages to the host or to your system Python. You always have to put it in some virtual environment or some other layer. Docker, that whole idea is removed because we don't actually have to think about it. It's totally isolated kind of by default. So, yeah. Well, go ahead.
I was gonna say that we got a question around that, so I might as well thought I'd jump in. Sorry for stopping you, but so Michael asks, ever use virtual environments inside of Docker or always install to the system Python? So I think what he's asking, and I have this question too, because I'm not a full-time Python developer, and I've seen it both ways, right? Of inside your actual Docker file, you install you're using it in a virtual environment inside of your container when it runs. Any thoughts around that?
Yeah, I don't know if I'm controversial or not, but I would say generally no. The big reason is there's nothing else depending on that Python and its dependencies. Like there's nothing else. Generally, when you deploy a container, it should be a process per container, and there's very few exceptions around that. So it's not an absolute, but it's a general rule of thumb. So you're not corrupting the system Python like you would on a host where, you know, some networking layer can't resolve like DNS because you changed out the DNS resolver for like a Python package.
Yeah.
So generally, I don't use a virtual environment in there. I think it's an extra overhead. You can, but I don't think that it really impacts anything negatively to not.
Yeah, that's my thought. You know, just by understanding the Docker and working with other programming languages and containerizing them, right? Yeah, that would be my default answer is, unless you have a specific reason to do it, don't complicate things, right? And like Matt was saying, you've already containerized and virtualized that process, right? It is isolated. So yeah, and when you would start to use virtual environments because you're running two versions of Python inside of a container, you start breaking that rule of one process inside of a container. So yeah, I would agree.
Yeah, and I think a really nice thing about that process stuff, and we'll get to that here, is you can actually isolate like networking stacks and secrets and environments, and there's so many nice pieces of composing these things together, where similarly with a virtual environment, not using one, it doesn't impact any other service by having that.
Right.
And I guess it'd be kind of interesting, like Python by default installs globally, whereas like, you know, if you're in the JavaScript ecosystem, it puts the node modules next to your project.
Right.
But that's just kind of, I guess, an idiom of how they work.
Yeah.
So, or I guess, let's see, bot. So let's step back for a quick sec. So we did this Docker build, and it shouldn't run again because we haven't changed anything. Sorry. So nothing changed here. But one thing you can do, like I said, it's kind of, if you don't tag it, you get this beautiful SHA, which is hard to run. So we can just like that. So we can tag it and then Docker images. So now we can run these things by tagging them. So instead of the Docker run we had earlier, Docker run, we can do it here. So this carries over into the Docker compose file. And this is, I think right now we'll focus on making the dev experience really, really nice. But all of these things translate to when you go to deploy it. So you can actually, you can set your image here, you can set a name, and this makes it just easy to reference later. Docker otherwise gives you a default name that I don't particularly care for, but let me step through these once I can type them. Docker file. All right, this should fix our boot loop issue. Here's another fun idiom in Python. If you don't do a Python unbuffered, and especially in Docker, and you print something out, you expect to see a standard out, it might not show for a while until it's flushed. So just a funny idiom. All right, let's do this so we can actually run it. All right, and then we have to define, so this is our application itself, and now we can start thinking dependencies. So we do image, Redis, and that's, then we can add up here. Again, this is really sweet because what we're doing is we're defining the graph or the relationships between our service and what it depends on our application, or when you do a really complicated thing, It's a bunch of them. I think ours at work is like 220 lines just to run our dev stuff. Let's see, secrets. I've actually just started using secrets too, which is pretty fun.
Yeah, cool.
I think the big reason, tell me if I'm wrong, is I think it emulates probably a more production environment better, and the secret doesn't, like, if it's an environment variable, it doesn't end up in your end image. Is that correct?
Yeah, correct. And it's yeah, it's a virtual file system too, so it isn't really on disk. But when your process reads it in, it to your process, it looks like a normal file.
Oh, okay. Yeah, that's thought it was in the like var run or whatever.
Yep.
And then, ah. All right, let's see. This should work here. And then need to move forward. All right, so the secrets, I'm not going to cat out, but those are all like all the things our app depends on. So your client ID, client secret, all that kind of stuff. Database credentials, if it's a remote database, all that. Might need to, yep. Do it live. All right, so I guess it does. Let's see, what's that? Never mind. I know it's an environment variable to have compose use the new CLI stuff too. So I wonder if is it a different cache? Probably.
Yeah, it's a different it's a different environment variable. Get top of my head, it's like CLI something.
There we go.
Yeah.
History for the win. There we go. Now we don't have to rebuild it. Cool. So what this did, we just booted up the app in Docker. It's now running in this container. Because we already had the cache, didn't have to rebuild. So that makes kind of some dev experience really nice. You don't have to keep reinstalling stuff. Although we'll show that that's not true in a second. But now it's running using the contained Redis, which is at this host name. And I think this gets into some fun stuff with compose. Kind of for anyone who's unfamiliar, these by default are going to be kind of in the same network stack, which is created for this based on this Docker files location or this compose files location. So Docker network ls. So you can see it's misbot default. So that's the default network that we're getting. And as such, they are just on the same network, and we can actually resolve this one by its effective host name, which is pretty neat. And we don't have to think about ports or any of that, because I think it by default what it exposes, I think, is what it would use. And then we can actually see if this dude works. See, that's not kill that.
Yeah. Quick note on that network name, the misbot. So that's being pulled from the directory that you're currently running your compose file in. So it'll so you don't get clashes if you were running two compose applications. It'll preface networks and volumes and stuff like that with the folder that you're in.
Oh, this goes to our issue. All right, cool. Now we can actually see the issue that we created for ourselves earlier. So because these are isolated networks and misbot is currently listening on 127.0.0.1, we actually can't access it, and that's just because it's not exposed to our host. It's in that private network, that network overlay. So we can fix that real quick with this Docker file and this. This is kind of a nice way to show how rebuilds will work, because the only thing we're going to change is this line, so we'll see what else happens. Okay. This is kind of funny. So the reason I think this is rebuilding, and this is kind of a fun Dockerism, something to just be aware of. It's not actually bad, but we need to add. You have this Docker ignore file, And basically what happens is when Docker builds your image, it copies everything from your host into it. And again, as Python people, we probably have talks, we have then, we have obviously our Git project, all that gets copied in. So in this Docker ignore, we're ignoring some of those things because we don't want those copied in. We want them isolated to our host, and we don't want to make what's called like a fat image at the end where it just gets just all this extra stuff in it. So we probably need to just exclude the Docker file. I wonder if I invalidated the cache on accident somehow that way.
Yeah.
Anyway, what's supposed to happen if I had excluded that, this wouldn't be rebuilding again. I'm gonna kill that because we're gonna move on to Dockerfile v2 anyway. But it would have only rebuilt that last line of the Docker file because nothing had changed in any of these pieces. The only thing that changed here, and Docker is pretty smart about, this value is based on the line, the contents, but when it's a file, I believe it's based on the actual or I guess it's invalidated here. So this is the file changed, it validates all lower layers. So in this case, it should have just done this one, but I screwed up with that Docker file, which is fine.
How dare you?
It's,
All good.
I'm good at messing things up. Let's see.
No, it's perfect. And yeah, just a quick note. It's very interesting the way that the caching works too. It'll actually, I think you touched on it real quick. So the requirements production txt, it knows it's a file, and it does. It'll actually look in the context in different kinds of ways to make sure that the cache was actually validated. I think it looks at timestamps, it looks at hashes and stuff like that.
Looks pretty cool. Yeah, it's really nice when it works, or when I do it correctly. It pretty much always works. So that was definitely my error. Let's do Dockerfile v2. And so kind of one thing when I'm talking about kind of making these fat images, these big honking, things you have to ship around, it's kind of painful. So like this one has a lot of stuff in it that we might not care about for development. We're installing our production txt, our production requirements for just dev work, and maybe we don't need all that stuff. I don't know, I guess you should usually emulate production. So yeah, for Python, it's a little harder to condense these a little bit because we don't build a single executable that we can ship off to people. Instead, in Python, we install a bunch of packages, and we have to have the C-links and all that. But in Go, you build one, and you just ship that guy. So let's clean this up. And we're gonna use multi-stage builds for that here. So we'll make a base image, and we're gonna thin this down where hopefully we actually leverage caching correctly. So in this case, instead of copying everything, let's copy our requirements to requirements. So we're going to copy all that directory. So the only reason that this cache should be invalidated is this folder. One of our requirements changed. And then similarly, we want to pip install our requirements, expose, and this is all probably fine here. And then from there, this is kind of a decent production image starting point we could use. But then we can actually do another layer which uses our previous image to build from as dev. And then this we can do some nice stuff for the dev experience to pip install our development dependencies. And then one of which is tox, which I don't put in my file, so if tox doesn't install itself. And then we can actually copy the rest in, and we could use the same one, but I actually like to add a flag to this. And again, this is one of those nice things that JavaScript had forever, and Python didn't quite as much. Some auto reloading when files change. And so that's pretty decent starting point. And then yeah, let's see. Then for production, we can do, sorry, copy everything in, and that way it'll just, and then this command will be by default what's happening here because we already defined it, I think. Build. Oh, sorry. One thing I forgot to comment on. Let's do this. All right, so now that we've changed this image and we're going to rebuild it, we can, since we have these different layer or these multi-stages we can use, since we're working on this in dev, we're going to want a couple things. First off is we're going to want the local directory, and you just do dot, to be at app. The reason being just we want all of our current files to be in the container. I guess we probably need a misspot, but yeah. Okay. And then the other big thing is now that we have a target we can do, we don't always want to run the production way, primarily because we're gonna just have extra stuff, and the stuff we want, which is our development dependencies, so PyTest and Tox and those kind of things, won't be in that final image, and it won't reload. So to make the dev image fun, like to make this comfortable and usable, we can add the target here as dev. And then, yeah, I did mean volume. Thank you, Docker.
We're very helpful and friendly here at Docker.
I'd say generally it's nice when it gives you recommendations, get similar. Like it'll be like, oh, did you mean status instead of stat or something? So, yeah, I did.
Yeah.
There's that nice command line app. I have not used it, but a lot of friends really like it. I think it's called the F word, and it tries to correct previous commands that failed.
I'll have to check that out. Yeah.
It's probably a good pick.
Yeah.
And similarly, this one's going to probably take a little bit since we changed the file and compose, or building it in compose.
So we got a question here. So Alexander asked, will these config files be shared anywhere for reference? You're going to put this on GitHub, correct?
Yep. I'll get on my GitHub.
Awesome.
And that'll be probably tonight. Let's see, or I guess right after this.
Okay,
Just
cool.
my name. Pretty boring.
And we'll get the link sent out with the recording.
Yeah, sounds good. Let's see.
Radu said
Come on,
looks like Radu said we froze here. Are you back on, Radu? We're okay here. Anybody else having troubles, just throw in the questions there or in the chat. You can chat to me, but.
All right, so I think last time was what, 140 seconds?
Yep.
Or so. This is the hard part of showing Docker, I think, too. Sometimes the builds, maybe a small flask gap it's a good approach, but it's fun to actually do something you're working on, I think, in Docker to share that.
Yeah. Just reading through some questions. Okay, Radu's back. Good. Yeah, it's probably was on your end. Hopefully, if not, if you get any more hookups, let me know. With everybody at home, and at least here in the United States, a lot of kids are still in virtual school. But they should be. It's 3:30 my time. But kids are finishing up now. Yeah, they basically kids are basically like working in corporate America these days. They just sit on Zoom calls.
Pretty much. I've heard of some have to do their homework on Zoom.
Yeah, I saw a friend of mine tweet out. My son said, "Oh, I don't want to go to school. All I do is sit on Zoom calls," or "I don't want to sit in Zoom calls all day today." And the dad was like, "Yeah, me too."
Yeah, plug my work. I think we're very good about not having a lot of calls, which is pretty nice.
Yeah.
So SFox is always hiring too, I'm sure, like everywhere right now, at least in the dev space, I should say. This is kind of nice output here. You can see what layer it's building. So we can see we're setting up our base layer. It's 5 different layers to build it. used these cache ones from probably our previous build and added some stuff. Docker file. Oh yeah, not that sharp. Build. Okay, cool. So again, kind of like I was saying, now when you're doing it right, there's actually caches. It's great.
I was gonna say there's the cache right there.
And hopefully things are working again. There we go. Cool. So our app's now back up. We're listening on the correct interface. You have to listen on 0000. Or I guess if you want to grab the Docker's IP, that's fine, probably too. And so now that's back. Let's compose. So here's a couple things that we did special. I think this target, so multi-stage builds, this is cool. And then we're using secrets instead of the environment for a couple of reasons we talked about. It's a virtual file system, so it's not going to be just in the image or on the file system directly. And this is what's really cool about secrets. You can actually use secrets in Docker build right now. And so if you want to do that right now, like a lot of people, if you're just installing from a private GitHub, you have to put in your key as a build arg. Just authenticate to download, but then it's in the image, it's in like the layer cache, you can inspect it, that kind of stuff. With secrets, I think they actually don't do that, so you can use it just for a command at a time, and it's not inspectable, so you could actually build your image with private repositories, compile your code if it's a compiled project, and actually ship that to people without them being able to get your, GitHub private or deploy key or whatever you're using.
Yeah, exactly. That
was pretty cool. I think it's something I need to roll out at work still.
Yeah,
so
for sure. And two, sorry, Matt. Yeah, I've seen in a layer in a Docker file, you add something that's sensitive data, and then a couple commands down, you delete it. Well, it's still in the previous layer, right? And you can inspect those. So, yeah, use secrets as much as possible. Keep your image clean.
Yeah, I think, come on, Matt. Yeah, I mean, you can see quite a bit, like the path, the pip hash, I mean, there's a lot of information in these and I think you can actually inspect even further when you have the layers actually pulled up. So right now, we put our app in Docker, we put it in Compose, we now volume mapped in our code. So now all of a sudden, like, all right, I want my dev experience to be good. And so we added reload. So let's do, this is just gonna be trivial just to trigger a restart, and hopefully it restarts, which it does. So you see up here, our bot just reloaded. So this can work for any application that supports live reloading. So if you're a Node person, JavaScript, whatever, it'll work there by volume mapping. And so since I'm on a Linux kernel in WSL, I think it actually supports like iNotify, which is like a nice way to poll for those changes. So every time you change, you don't have to like kill and restart your app. You don't have to rebuild Docker. You don't have to do any of that stuff unless you change, a base layer. So like we had a dependency or whatever. And then even better, I think a kind of a nice bonus we can tap into here is, all right, so now this is just a YAML file. Most things from YAML we can actually use here. So if you're the type of person that likes to run your tests every time you change a file, you can just use some YAML anchors. I don't know why I copied all that because none of it's actually useful. Yes. Because what we can do is we can now anchor our bot. Wow, can I? Bot. So now what we're doing is we're saying, hey, I want to run another service that uses all this exact same stuff and do it again. But there's a caveat is certain things can't work. So we have to say, don't use the ports. We do want most environment other than SSL. So again, just using some nice YAML features. I know a lot of people hate YAML. A lot of us code in YAML every day for work half the time, but can override some of these so we can actually run our tests on live reload. So then we can change the command out and we'll override what was in our container, which would be would you so I just have to look at notes to remember.
I was gonna say, it's pretty impressive if you remember all those.
No, I actually just right before we got on here, I was like, I should make this do this because it'd be really useful. All right, let's see if this one actually works. Oh, the name. Yes, that's a bad part of naming them by manually. Recreating. Did I type that wrong? I'm not sure. Container name.
I don't know, your terminal fee was too fast for me.
I think it Docker Compose is still running.
Ah. Yeah. There you go.
Sorry, I do jump around a lot. My fault.
No worries.
Okay, let's see if it works this time. All right, so again, 2 images using the shared cache because it's the same image. We're using our dev dependency one, and this one's already satisfied. This one's built. So now we should be able to get not only live reloading of our project, but we can also have our tests run automatically. So every time we change something in our file, these tests run. It's giving you a warning about our time zone that we're not configured. That's probably something we should do in the Docker file. We should probably also set up another user. But in any case, this is now shareable with your colleagues, your friends, open source system, whatever. So when I push this, ideally speaking, anyone here, if they wanted to contribute, could kill it. There we go. Could literally pull down our project, run this, and be off to the races now contributing. So think about like leveraging this for your teams at work or open source. Now your colleagues like, hey, I don't know how to run the project. Well, this is a way to get started. And then if they want to, go outside the realm of normal, they can do that. But I think this is pretty awesome. It shares, configurability, the runtime is pretty cool. And then what we can do from here, we can leverage Docker kind of to do something, something fun. So you can run this using Compose on servers very easily and strip out some of the stuff. We're actually gonna get a little. We'll go to one of my servers real quick. I'll probably have to change one of these passwords because I think everyone can see this. But this is a Docker Compose I have here running, and this is to replace. If you see this command up here, what I'm doing I'm basically replacing ngrok. So anyone who ever's written a bot or anything might be familiar. You have to TCP forward. You generally have to use an HTTPS host name or domain. And to do so, you have to use something like ngrok or something else. So to get around that, because I don't want to pay the money, I have to keep changing my URLs. I basically set this up all with Docker on a server where I can port forward from there to my computer here. So all it does, so I have an OpenSSH server that we port forward through, and we get automatic SSL because the way Docker works is the whole runtime shares events and everything, where you can have like automatic TLS created for you for your host name. So this is automatically managed, and I could share this with my project and put in basically anybody's public key and not feel scared because my server, this is in Docker, and again, we talk about this isolation. It's isolated from the host. It's isolated from other containers. It's isolated from the file system even. So, I could give anybody access to this, and it doesn't really matter because you're in an isolated environment. So this is all it is. And that's a Linux server. So we could kill it by deleting everything. But if you did that, it didn't matter. Actually, you can't because it's not even root. So this is a nice part about using the user piece is now we can isolate like kind of some of our infrastructure pieces. So VPNs and SSH service, all that.
Yeah, nice.
So, yeah, it was kind of a bonus one. I thought I was like, that'd be cool if people can see that because it's pretty simple. All levers through Docker too.
Yeah, cool.
I think we probably look at questions. I guess I don't have a ton more. Well, I mean, I have a few other items if we want to get into it, but
I think we're all good on questions. If anybody else has a question, drop it into the question section. And yeah, this has been awesome. This is great. So we'll get this, like Matt said, he'll push this all up to his repo, and so you can pull it back down after recording. I believe later tonight you should receive an email that has a link to watch the recording. So if you want to replay it and clone the repo or fork the repo, and play along, right, and see everything that Matt has done, and apply some of these to your Python projects, right? Super helpful. And if you want, you can then tweet at me. Let me know you're working on it. It'd be cool to see people going through the demo themselves. But yeah, if anybody else has any questions, go ahead and drop them in the questions. Other than that, we're pretty much done. Yeah, we covered a lot. That was super cool. I definitely had. I'm not a I program in Python, but I am definitely not a professional Python developer. I can program in many languages, but it's different programming in a language to playing around and doing demos than to building production world stuff, right? Someone's actually going to use. So I really appreciate you coming on, Matt, and going through this for us.
Yeah, thanks for having me. Glad we could cover quite a few steps, I think, in Docker and how useful it is.
Yeah, for sure. Well, thanks everybody. Yeah, I don't think we have any questions. So you are welcome, Radu. Thanks for joining us. Thanks for everybody for showing up. Look for the replay again. Should be in your inbox. If not tonight, definitely tomorrow. And we'll drop in there the GitHub link. And yeah, thanks everybody. Really